The law of conservation of energy tells us that energy is always conserved. Now, we know that in our daily experiences, we find instances in which energy does not appear to be conserved. So, in this case, it depends on the system or what we're actually looking at. So, when we say energy is conserved in the universe, we're putting the whole universe in our system. So, the whole universe. But if we are looking at maybe a car, and that's the only thing in our system, and maybe the car has gas because the gas is inside the car. Well, we know, because we have to go to the gas station later, that there will be energy exchanged and it will leave the car because the car goes, and then we have to go and fill it with gasoline again. And maybe the car is also stopping, so there's brakes, and the brakes scrub on the rotors and the tires become hot, and there is an energy transfer there. So let's look more specifically at energy loss from a system. So let's say, for example, there is a car, and here's the road, and our car is moving along on the road, and this car is going and has a velocity, an initial velocity. And the car then stops, maybe puts on the brakes, and over here, the velocity of our car is now 0, and it has stopped. So what was happening from the moment the car was moving over here to being stopped over there? Well, the kinetic energy, 1/2 m, the mass of the car, times the initial velocity squared, and the kinetic energy later, 1/2 m, v final squared, is different. This final velocity is 0. So that means that our kinetic energy final is 0. And our initial kinetic energy is some initial value. So what causes this change to occur? This change is caused by work. Work changes energy. Remember, work is equal to a change in kinetic energy. So let's apply this. Here's an example. A block with a mass of 2 kilograms slides across a rough, flat surface. The initial velocity of the block is 10 meters per second. The block slows down and stops. So what is the change in kinetic energy of the block? The change in kinetic energy would be the final kinetic energy minus the initial kinetic energy. The final kinetic energy would be 1/2 the mass, 2 kilograms, times the final velocity, which was 0, squared, minus 1/2 m v initial squared. This gives us 0 minus 100, which would be negative 100 joules, is our change in kinetic energy. So what does that mean? That means that our kinetic energy changed by 100 joules. The negative tells me that the energy left the system. So when I say system, I'm referring to if I were to just consider what's inside my circle where it's just the block. The block is the only thing I'm interested in. Initially, there is energy stored in the block because it's moving. And so I set up a graph to show me that there is an initial kinetic energy in this block. Later, though, when the block stops, our kinetic energy final is 0, indicated just by the straight line there. So, if energy is supposed to be conserved in the universe, why am I missing energy blocks on this side? Well, the rough surface along which the block slides applies a force of friction. Remember, the force of friction is mu times force normal. So this force of friction can do work. Work is equal to a force that's parallel to the distance times the distance. And in this case, we have work being done by a friction force. So it would be negative, because friction acts in the opposite direction, times the distance. And so this negative right here connects to this negative there. So this work done by the force of friction removes energy from my system. And so I'm going to draw that in my picture like this. I'm going to have 4 blocks, 1, 2, 3 for 4 blocks. And I'm going to draw an arrowhead here to show me that this is the work done by the friction force. And that leaving the system, so all of these chunks of energy that are leaving my system, so this is my system, everything I've put in my circle there is there's a reduction in the energy because the friction force is doing work. And remember, work changes energy. Work changes the kinetic energy. So this force of friction right here is doing work, which causes my change in kinetic energy. So where does that energy go? It goes to the surface. The surfaces become warm. Just like if you were to rub your hands together, you would feel them become warm, and that's because they are rubbing against each other. Some of the energy stored in your body is being converted to mechanical energy as you move your hands back and forth, and you feel your hands warm up. And so how much energy was transferred out of the block system? Well, if this is a change of 100 joules, then this work done by friction would be equal to 100 joules. Initially, this kinetic energy was 100 joules. Later, our kinetic energy is 0. So that means that the work done by friction was equal to 100 joules.